So, good morning, welcome. Thank you very much for turning up to my first session of the week. Today, for the next 45 minutes, I'm going to talk to you about two customer case studies for work that my team did. Why do I want to do that? Well, because there are lots and lots and lots of sessions at Ignite and other conferences about what logic apps are, what functions are, what all the really nice Lego bricks are. But for some reason, nobody does case studies on logic apps and integration. So I spotted a gap in the market, and we'll see how this one goes. So what I'm going to talk about today are two scenarios. One of them is a charity. So they're very focused on price. They're very focused on the cost of running and the cost of development. And the information that they're moving around is precious to them. Precious because it's all about donations. And without those donations, they just can't run. The second one is the complete opposite end of the spectrum. It's a huge retailer, and they're shifting large amounts of money around. So they're less price sensitive to the solution itself, but they're really sensitive if we lose any of their data, because millions of pounds go missing. And what I'm going to try and talk about is what the designs look like, how we tackled the scenarios at hand, how we went through and iterated our design, and why we picked the final choice. And I'm going to talk about what did we learn on the way for each of them. What bit us, what went well, and bluntly, if you squint, what are the similarities between the two? So let's start with our charity and talk about what it was that they were after. So they approached us because they just bought a new CRM system. And this was an on-premises solution. And their payment management system, which dealt with incoming donations, was hosted for them by a solution provider. And when we encountered them, basically, their current system was if payments came in, they effectively copy-pasted between the two systems. So they'd got real people rekeying information. And as I'm sure you know, humans are fallible. So they had problems of things just not making it across there. Sometimes things got missed, lost, miskeyed. And for them, that had a genuine cost because, my donation to the charity didn't make it into their records, and there's an impact to that. As I mentioned before, they were really sensitive to how much time it was going to cost us to develop this, but also how much time it was going to cost to run it. So one of the principal aims of this project was to try and make the Azure billing as low as possible while still delivering a reliable, appropriate solution. Just to make our life easy, the reliability of the CRM system was not necessarily great, and the supplier acknowledged that there were some issues there. But on the bright side, the supplier was also totally willing to work with us on how we were going to extract that data from CRM and be able to push it into the payment management system. The customer was absolutely adamant that whatever we built, there could be no supplier lock-in. Now, I don't mean supplier lock-in to Azure. Apparently, Microsoft doesn't count as a supplier in that kind of lock-in regard, but they absolutely wanted to make sure that if they fell out with me, because I'm lovable, but I'm not perfect, that they had to be able to take whatever we'd built and give it to another partner and say, continue supporting and developing that. And then last but not least, they'd had bad experiences in the past. So there was an absolutely adamant, not going to go away requirement that we could not die silently. If a piece of information left system A, did not make it to system B, they wanted to know. And they didn't want to know by some blinking light on a dashboard somewhere. They wanted something that was going to be integrated with their business processes and visible to the team. So, quick straw poll. What kind of audiences have I got? How many of you think of yourselves as developers? Okay, so that's, I don't know, third-ish. IT pros? Yay. Architects? Okay. Project managers? Cool. Right, so that's a really good mix. So one of the key things when you're designing these things is you look at your box of Lego bricks, right? And you say, okay, well, what are we trying to do? Out of that wonderful menu that Azure gives us, what are the appropriate components and technologies that we're going to pull out? So we sat and we asked ourselves what we needed. Whenever you're doing integrations, you almost always end up putting some kind of queuing system in because we need to be able to cope with rapidly changing scale, right? And not lose any of those messages as they come in. So that one's nice and easy. We'll take service bus for 10, please, George. Next question is, how do we actually manage to process those records? So we can either work on sort of push, data comes in and taps us on the shoulder, or we can pull, so we can go and look for it. And do we look for trigger, so something like event grid maybe, or do we poll? And there's pros and cons to all of those that we sort of work through. And then we get to, well, what's the data that we're moving around? What is it that we're actually hefting between system A and system B? Because that has implications for the technologies we choose, because some of them are better than others at different kinds of data. Now, if we want to honk around large image files, then that might be a different solution than if I'm just throwing tiny little XML payloads or bits of JSON around. And then last but not least, and almost the most important one, is what kind of volume are we talking about? What does the pattern of information that's flowing through the system look like? You know, is it a million messages, but they arrive between 5 to 9 and 9 o'clock on a Monday? Or is it like, I don't know, one transaction every couple of hours? Or is it a steady stream that we're going to drown in? What does it look like? So once we've got a rough idea of the components that we're going to pick, then, just like little kids with our Lego, let's design a few things and start poking holes in those designs and seeing how we can iterate and how we can improve them. So I'll start off 10, and I will say, the slides are obviously going to be up on the Ignite site shortly. They'll also be on my GitHub by the end of the day, so don't panic if you've got to squint at the text. We always start with a push architecture because that's usually the one that's most straightforward to conceptualize. So the consultant perfect world, we've got to get data out of the source system, and when we looked at that with the supplier, they said, okay, well, look, we're running on a SQL server. We don't have any kind of API. And we went, that's great. We don't really want to look into your database directly. Thank you very much. So what we agreed with them is that we'd build an SSIS package. And an SSIS package, as it turns out, happily, can poll an HTTP endpoint. So when there's a change to the database, our SSIS package is triggered. So when they insert a new contact into the row in the CRM system, we fire an SSIS package, which grabs the data we need and calls an HTTP endpoint in the cloud. Result, more importantly, we don't have to build that bit. Great. So our SSIS package, conceptually, we thought, okay, well, that's great. What are we going to call? An endpoint, the most obvious endpoint is let's call a function. And that function has one job, to say, thank you very much for my payload. I will now put it on service bus because we want a queue. Oh, we've already got a question. Go on then, Martin. Okay, so that was a very good question. So the question was, this CRM supply, did they place any constraints on our access to the database? So the answer is, they did this. In fact, what actually happened was they assumed control of the SSIS package. So they looked at the solution and validated it that we weren't going to put excess load on the database and bring the whole thing down. Remember that question when I talk about scenario number 2. So we've now got our messages on service bus. How are we going to dequeue those messages? How are we going to manage that? Now, Ricardo, who was the consultant working for me that designed this, is a big fan of event grid because he totally drunk Dan Rossanova's Kool-Aid. and said, right, okay, so service bus will get an event grid trigger, and the event grid trigger will fire the next thing, which will be the logic app, which will take the message off service bus, look at the contents, and then we'll squirt that into the API for the CRM system. Brilliant. We need some kind of telemetry. Remember I said that we couldn't have any failed solutions. So, okay, we need to put App Insights in for that. So we've got all the basic moving parts. Great. There's some pros and cons to this architecture. It's really, really fast and scalable because Service Bus will just happily queue up all of those things, fire off events, trigger the logic apps. Brilliant. It's reliable and resilient because Service Bus is battle-hardened, proven technology. The only snag is, much as I love Event Grid, it's not that cheap when we start looking at the monthly costs. And yes, to an enterprise, the few £100 or whatever it was going to be is nothing. But to a charity, where what they really want to do is spend their money on the people they're trying to help, that was probably going to be vetoed as out of budget. So Ricardo cried into his beer for a bit because he really wanted to use Event Grid and went, well, okay, fair enough then. Let's try pull. So we're going to keep our SSIS component, we're going to keep the function, we're going to keep Service Bus, but instead of firing off an event through Event Grid when we get a message, we're going to have the logic app poll. Okay, so we're just going to stick a logic app, Service Bus trigger on the logic app. Now, what actually happens with that is the Service Bus does a HTTP long poll. Now, for those of you who don't really know that much about logic app pricing and charging, every time you fire an action in a logic app, you get charged. So because that logic app is polling, every time it polls, there's a pay-to-play, cost per click ramping up there. So it's a relatively elegant solution, and it's significantly cheaper than the first one because we've taken Event Grid out. And despite the fact that there aren't really any cons to speak of, you know, it ticks all of our boxes, we sat there and thought, we're sure we can do better than that. Because we're Yorkshiremen, and we've got deep pockets and short arms, and we understand the needs of our customer, okay? So, enter stage left, our final design. Now, I will say final pre-production design. Now, you'll notice that this one looks slightly more complicated. It is a bit, but only a little bit. So we've still got everything up to Service Bus is exactly the same. But rather than having the logic app poll, we have a function polling. And basically, that function is on a timer trigger. So it pops up, queries Service Bus. If there's a message, dequeues it, hands it to the logic app. In a consumption plan, for that service, which is going to fire and die so quickly, we can be confident that we're going to get our first 1 million executions to be free. If you do the maths for a normal month, that means I can fire that function once every 3 seconds and not pay for it. I like that. I can live with once every 3 seconds for checking for Service Bus messages, right? Works for me. Obviously, we did some due diligence on this one to make sure that our flow rate of the data coming in was not going to be something this was all going to suddenly hurt itself when it started running. But at that point, we thought, ha-ha. So now, we've got our following the customer requirements, cheapest chips design. We have not sacrificed our reliability. We haven't sacrificed scalability. Everything's serverless. This thing will scale up if it needs to. But the one downside is that actually we've got more moving parts. Now, in this scenario, we didn't care about that. Even with the it must be maintainable by another supplier, we've only added one thing, right? And it's a function, and it's going to be like a dozen lines of code. That's not going to be an issue. But you really do need to, when you're architecting these things, constantly check yourself and validate and say, have we overcomplicated this? Is it going to be maintainable moving forward? Could I just drop somebody who'd never really seen this design into the project and say, can you make some changes? So that's the thought process that we always go through as we're working on these. So we've got our basic architecture. Now we need to make it work in production. And another question from my favorite Australia. Yep. I am coming to that. So the question was, what happens if we fail to process? Because he's sharp. That's why he's a regional director. He's sharp, is my friend Martin over there. So this is what production looked like. You'll remember in that first slide, I said we could not silently fail. So the bit at the bottom of this slide that we've added now is all about how we deal with that. And you'll also notice a whacking gray orange padlock. That is key vault. Never, ever, 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 ever put your secrets, well, in source control, I might have to really hurt you, but please don't put it in config. Put it in a secret store. So we've added our key vault so that we can get whatever necessary connection strings and passwords and all that kind of stuff out for talking to our various systems. And then the next thing we did, which is what Martin was talking about. So what happens if we fail to process? So if the logic app fails to process, then basically what we were doing is we're using something called a peak lock pattern, okay? So there's a message on service bus. Think of it a bit like poker. So I've got my cards on the table. I can see that there's one there. I sort of have a bit of a sly look under the card, and I'm going to do something with it. If I suddenly have a heart attack, that card's going to end up back face down on the table, at which point Martin can go, ha-ha, and steal it. So the idea of the peak lock pattern is if I fail during my processing of that message, the message goes back on the queue, and we can retry. But we also made it so that if we failed 3 times, we'd spot that. And we had another logic app which would then be triggered, and that was going to do our alerting of the customer. So that logic app noticed this thing, so this function even, noticed that we'd failed 3 times, and called a logic app which was an error handler, and that error handler did 2 things. It was connected to Teams, so it posted in the Teams channel, and it sent an email. But Rick, I hear you cry, that's unnecessary expense because you said very clearly you've got application insights and that does telemetry and surely you could make that alert you when it failed. Yes, I would say, but it's a bit laggy. Logging and telemetry coming into App Insights, particularly log analytics, that I can then put an alert on, probably is going to be there within 5 minutes, maybe. Hopefully. And that kind of reliability we just weren't terribly happy with. And the alerts as they stand, I'm looking at something relatively simple like firing off an email. We wanted something that was going to be directly integrated with the line of business processes that the admin team were using. And they were using Microsoft Teams, so we drop a message into Microsoft Teams. And that's actually a really key point. It's very, very easy for us as technologists to go, yeah, we can handle errors, yeah, we're going to have a dashboard, but if that dashboard's in the Azure portal, and to be fair, there is a dashboard in the Azure portal for technical people to look at, but business users are not going to do that, which means they're never going to learn that things have failed because we'll never tell them. And sometimes we have to deliberately engineer in a non-technical solution because we've got non-technical users. Even though it's an integration system, I've spent a long time working on things like BizTalk that just sort of sit in the back room and hum. But we really need to surface our issues to our customers. So, what did we learn on this one? So the first thing that I want to get across that actually sort of took us by surprise, if you like, if you're prepared to invest a little bit more time up front in just working through and critiquing, and to an extent being harsh with yourselves, do a bit of peer review on those architectures, sometimes you can come up with an innovative idea which is better for the customer, even though you're looking at it going, we've made that more complicated, that can't be good, what have we done? Related to that is the obvious that the most technically elegant solution, SOB, event grid, SOB, is not always the best thing for the customer. If I had £1 for every organization I've been to that suffers from CV-driven development, I'd be a very rich man. I'd have at least £2. It's our job as practitioners to continually think of our best advice for that customer, not what we want to learn for our next project. You also need, absolutely when you're running in the cloud, to design with instrumentation in mind from day one. Now, to be fair, they try to make it really easy for you, because functions and logic apps, everything just sort of plugs nicely into application insights. There's a telemetry layer already in Azure. But it's not going to do all of the work for you. And if you start joining and chaining logic apps and functions and service bus and that kind of stuff, you have to think about how you are going to correlate messages coming from those different systems to work out that it's one transaction. So you have to put some kind of correlation ID, some kind of unique identifier that you can pass through the stream and echo out into your telemetry. Because if you can't isolate the error message to a specific run of the logic app, a specific input of data, then, well, you haven't actually got telemetry. You've just got white noise coming into something that's going to draw you a pretty but meaningless graph. Okay, so having gone through all of that, remember those pictures in your mind as we enter scenario 2. So this is a retailer in the UK. As it turns out, a honking great big retailer in the UK. And when we started this project, they had a legacy system. And what this system did was it processed all of the sort of stock and order records in one direction and invoicing and payment in another direction for the retailer to deal with all of its suppliers. Some of those suppliers are very big. That legacy system, cough, MuleSoft, cough, cost them about £2 million a year by the time you'd reckoned up the outsourced management and support and licensing. That's quite wallet crunching. And I'd like you to remember that number as I work through this part of the presentation, and I'll tell you how much we actually got it to cost when we finished. So their big driver was, we want to get rid of this cost. We want to think about putting something in that is manageable, that's scalable, that's cost effective. But it's got to be quick. Okay, so it was an acquisition. We went in within, I think, a week or so of them taking over, and they said, well, if you can get it in by next Thursday, that'd be great. We accept that's going to be hard, but if you say 6 months, we're going to shoot you in the head and go and talk to somebody else. Fair enough. Reliability and uptime of this thing is absolutely critical, because if it's not running, we can't get money in and out of our suppliers. We can't get the stock records in, we don't know what we're ordering, we can't get them to pay for it. Now, the customer had a technical team, and they had some principles. So they wanted something that was going to be scalable and manageable. They were adamant that they wanted event-driven, which made Ricardo a happy man, because he really likes event grid. And the other one was the customers are not going to change any of their systems. So as far as they're concerned, this has to look exactly the same as the one they had before. They cannot notice that we've taken the old one out and put the new one in, so we don't want any delays. And you absolutely cannot mess this up while you're doing it. So no pressure, just saying. So we tackled this in exactly the same way. We sat down, we looked at the Azure services, the Lego bricks that we thought we were going to use, and we iterated through the questions that were in our minds. Now, the biggest problem we got with this one was our message formats. So the customer, pause. How many of you are familiar with EDIFACT as a means of exchanging data? Okay, that's fairly reasonable. So EDIFACT is one of those honking great standards that's been around for a long time, right? Now, I didn't know that much about it in depth until this project. It turns out that the first published iteration of the standard was actually EDIFACT 93. And as it turns out, when we got onto integration accounts, things like that, that's the earliest it works on. Yeah, we were using EDIFACT 90.1, which is an alpha release of the standard, with some additions that they'd pulled from one of the post releases. So one of the things that we had to do really early on was look at what formats we were talking about. And the adherence to those schemas was critical because we couldn't break any of that existing interchange. So we had to really think about that one. And I mentioned uptime and resilience. So just one supplier, so there's an integration here basically per supplier because they've got different formats and things. £17 million per week was the level of the stakes for if we started losing things. And our good old faithful, it will not die, it will not go away. All of the inbound, outbound connection to the customers was SFTP. So, with this one, we push to an on-prem system. It's actually the suppliers that are driving this pretty much at all times. So what we came up with was logic apps with an integration account. Because integration accounts are built to manage your schemas and do transforms. And it turns out they're really good at it, providing your files aren't like 100 meg big. And I'll come onto that in a little while. The disappointing thing, so I've been an Azure MVP for 6 years, and I have friends who've been Azure MVPs for more than that. And every summit we go, please can we have a first-party SFTP service, please? We'll sacrifice an Office 365 MVP to get it, we don't mind. But there are no first-party services for SFTP, so we had to find one. But remember what I was talking about, we need this thing to be event-driven, we want it to integrate. So that meant that we had to look very carefully at those marketplace solutions for FTP and work out, could we find an FTP server that we could integrate in a nicely elegant way with what we really wanted to design. And then because we're talking to on-premises systems, Oracle, I'll talk about that in a bit as well, that meant that we were looking at using the on-premises data gateway so that our logic apps could peer into the customer's network and talk safely and securely to systems. So we've got some moving parts here that we didn't have in the previous one. Well, broadly speaking, it sort of looks like this. So we have a set of integrations, and to be fair, we're continually adding more as we work with the customer to do specific functions. When you're building logic apps, top tip is try and make them uncomplicated. I had an interesting conversation with a customer a little while ago who said, our logic apps take ages to run and they're really expensive. What do they look like? I said, well, it's not so much a they, we've got one. It's got 50 odd steps. Okay then. If you're using cloud integration components, think about chaining things together. Now, that's important for our starting architecture because, so what we had, we've got our FTP service, which was a really nice marketplace service because it will drop files into Azure Blob Storage. Now that means we can use storage triggers to fire off our integration. So, at the point that we started this project, some of the things that are available now, that I'll talk about in a sec, weren't there. So all we can do is a storage trigger. I've got a new blob. Storage trigger fires, and we need to do something with that. So what we did was we had one logic app that would fire, and it would read the path to the blob. And by doing that, it would work out which of the other integrations it then needed to fire off. think it was that way. Anyway, so we've got our event-driven. We've got some kind of sort of processing node, if you like, which its purpose is to fire off the bits that actually do the work. The integrations are talking to the integration account. So they get their incoming payload. They throw it at the integration account, call that, get it transformed. And then we call the Oracle connector to stuff it into the on-prem system. Or at least that was the plan. So we had some issues. So the first issue, which Ricardo likes to say, there's always a bigger fish. The customer gave us all these lovely little EDIFACT files of a few K. Brilliant. What the customers actually do is send them in honking great big files of like 100 meg plus. And they're quite difficult to process. And actually, they're difficult enough to process that they're outside the capability of the integration account. And at this point, you've got to start getting quite innovative. As it turns out, really innovative. So you'll have noticed on that previous architecture slide, there was a little blue circle in the bottom corner that I didn't mention, which was called large file processor. We had several issues with timeouts between functions and logic apps and reading files, that kind of stuff. We had issues with maximum payloads we could send. So what we did was we built an app service. And if the file is over a certain size, rather than calling the integration account directly, we call our large file processor. What the large file processor does is it actually talks to the integration account, and it reads all the schemas from the integration account. It then streams the assemblies from the integration account, loads them through reflection into app services, and uses the logic from the integration account inside itself to do the transform for us in a virtual machine that's big enough and hard enough to actually not die while it's doing it. And then we pass it on to the next step. The downside to that is now we're doing something that the integration guys just didn't expect. So you've got to do this with some care, and it does help that we can talk to the logic apps team and go, we're about to do this. Is this really going to hurt us? But sometimes you end up in a situation where the only way out of it is a complete left field solution. And you shouldn't be afraid to try and play and build some of those kind of things. The second problem that we had, I'm talking tomorrow about governance and the car crashes you can have if you don't have any. Enter stage left the fact that we had an FTP server. And other teams went, woohoo, an FTP server. We can use that. As it turns out, a system built to process XML schema data exchange files doesn't work very well when you upload image files for your website to it. We fire, we charge you. We fail elegantly because we just go, we don't recognize the data, but it can get expensive. And the other problem we had was our customer was working on other projects at the same time, and they were dropping other files into the FTP server that actually did look like things we could process, and we would try to process them. But they had a bug, as it turned out, in the integration service that was throwing those files in, which it wrote the files out, and then it would fire again, but it didn't clean up. And on its end, it didn't clean up the files that it was generating. So it would fire and create one file and hand that to us, and we'd fire and process it. And then it would fire and generate a new file, and pick up that one and its predecessor, and hand it to us. And we will process both of them. And then it would do 3, 4, 5, 6. Over the course of a weekend, we came in on Monday morning and looked at our telemetry and went, what the, $5,000? Because this thing had just exponentially fired files at us in an area of the FTP server that actually we shouldn't necessarily have been looking at, but we were picking them up and checking to see if we had to do any work with them. So, part of the moral of this one is, when you've built something, you have to be prepared for those left field issues where you go, have we just totally got this wrong? Step back, look at the architecture and go, well, where's the problem? And is there a way around this? And more importantly, have the underlying products we're using changed in such a way that it might get us out of this particular crater? And the answer was yes, it had. Because in the intervening few weeks since we started the project, they provided something called event grid filters. And what that meant is on our logic apps, we could specify very clearly what the event should look like that we want to process. And we knew exactly what folders and what blob containers we wanted to be triggered by each of our integrations. So that first function that existed to fire and process, we took out and we replaced with event grid filters on the actual integrations themselves. What that meant was if somebody put a blob that we didn't care about into our FTP server, if it wasn't in the right place that we had to process, we just ignored it. And then we went and enforced some governance on our customer as well and went, look, please, this is our FTP server. Don't touch that FTP server. So, connectors for logic apps are an interesting beast. And it's unfair, as it happens, to have a go at the logic apps team over this, because actually most of the connectors for logic apps are not written by the logic apps team. You'd like to think that the Oracle connector was written by a team that are Oracle specialists. You'd like to think that, wouldn't you? You really would. So the original idea for this is that we would be talking to our customer's Oracle system, and their DBA said, right, this is going to be really easy. We're going to set up a sprock. We're going to have a store procedure that you're going to call, and we're going to do some processing, and we're going to hand you back a block of data. Brilliant. And, well, that got interesting. So the first thing we found was when you do that, so when you fire the Oracle connector with your integration, it doesn't just call the stored procedure that you want it to. Oh, no, that'd be easy, wouldn't it? It talks to the Oracle database, and it looks and generates a list of every single table and every single stored proc in that database as a background process before it'll actually call them. We're talking to a honking great big mission-critical database. Oddly enough, there's a lot of sprocs and tables in there. That took a long time. As the customer's going, this thing's really slow. You guys are crap. The other thing we found was that the connector can cope with about 300 requests a minute through one API connection. Now, you can multiplex these things. That's brilliant, but we were getting a lot more files in than that. By the time we'd finished, we'd got 4 honking great big virtual machines running on customer prem with data connectors on, running load balanced. And it still couldn't cope and keep up. And then I have a list here my customer sent me, because he spent a while working through all the things that the Oracle connector cannot do. It doesn't support out parameters on sprocs. It doesn't support clob. It doesn't support functions. So you can't use things like date when you're calling it. So my message to this is, if you're working with Oracle systems, our key learning is do not use the Oracle connector at all. Our customer does stuff with their files on-prem. They generate physical files, and they drop them on the FTP server, and we push, pull that way. And if there's one thing that I can save you from at the end of this session, it's just don't bother with the Oracle connector. That is not to say that other connectors are bad. The HTTP connector, all that, they're brilliant. But my ask of you is, can you please tweet, post, shout at people for the teams to open source the connectors? Because then people like us, other MVPs, will help, and we'll fix them, and we'll make them better. So I said that I would come back to how much this thing costs. So we've got 7 integrations. With one of those, we transact 17 million or so pounds a week. Would anybody like to hazard a guess at the monthly cost of all of the components for that integration? Fire out a number. Anybody? Not even you, Martin? 450 UK pounds it costs us, which is a fairly significant saving on 2 million quid. So, conclusions. The reason I really, really like the components in Azure for integration is because it's the same Lego bricks for big or small. And actually, the same design patterns and the same validated architectures that you can find on the docs.microsoft.com site, that kind of stuff, they work really well for big and small, and they scale really well, and they're reliable, and they're pretty quick and easy to build. You need to be a little bit careful as to how you implement them. Like I said before, logic apps should be a small number of steps, and they should call other logic apps to chain together. Don't make them 50 steps, because debugging and management is hard. You should always take a really critical look at what you've designed with the little voice of the customer echoing in your head. Because what you think is a glorious, gorgeous, elegant design might have flaws because of specific needs your customers have, and you might need to come back to the drawing board. And you should absolutely be prepared to evolve and change during development based on feedback from the customer, based on those left field, oh my God, why are you sending us a JPEG? And you should always keep an eye on the product team blogs and the documentation site, because the chances are that that thing that was really hard 3 weeks ago, somebody's just put a little tick box and it'll do all the work for you. Because the cadence of cloud solutions is completely different to things like BizTalk that we used to use. And finally, telemetry is your friend. So the only way we managed to work out what was going on when we got that exponential issue through the FTP server was because we'd got a whole boatload of analytics going in to our app insights, and we could see what was being triggered, and we could look at the individual logic apps runs, and we could trace it back to what file triggered it. If we hadn't done that, we wouldn't have been able to work out what was going on, and the chances are that every weekend it would have cost us another 5-ish, 6-ish grand, I think it was, that cost us. And why should you use these technologies? Well, because speed of delivery is an incredible benefit. We got that first integration up and running for that retail customer in less than a month, which, given some of the complexity we had to work with, I think is not bad. And we added another one and another one and another one every sort of 2 to 3 weeks, and we're continuing to keep that pace. With that, with 1 minute and 40 seconds to go, I'm not running away. If you want to talk to me, if you want to ask me questions, absolutely feel free. For most of the week, you'll actually probably find me hanging out around the Global Azure Bootcamp booth, which is down in the community zone. I have been Rick Hepworth. My day job is Chief Consulting Officer at Black Marble, and I'm an Azure MVP. And I would like to thank you very much for your time.